5.6, there are more chemical calculations, and the focus lies on finding the empirical formula and finding the molecular formula. The molecular formula you know already. That's basically the formula for a molecule. The empirical formula shown here is actually, it shows the ratio in which the elements appear, but not in their real number. We're going back here. Here we can see that the molecular formula is C2H6, while the empirical formula is C1, one could say, H3. The ratio of carbon to hydrogen is 1 to 3. Same in the molecular formula, 2 to 6 equals 1 to 3. So molecular formula is the actual molecule, and the empirical formula just gives you the ratio. Now, you think, why do we do this differently? That's because to find these numbers, or to find the molecular formula, you do different tests in practice. There are certain tests with which you can find the mass, the relative formula mass, and in that way you know, okay, that's the total mass. And there are other experiments with which you can find the empirical formula, the ratio of the elements. Again, there are other tests where you can find the elements. So once you have the information about the empirical formula and you have got the relative formula mass, then you can find the molecular mass. So there's a worked example in 5.6 for you to study. Now, for the empirical formula, we actually did already an exercise on the handout using moles 6.2. Question 2 at the bottom reads 168 grams of iron react with excess oxygen to form 232 grams of an oxide of iron. The reaction is given in words. Iron and oxygen give iron oxide, and there are different kinds of oxide, and that's what they want to find out. They want to find the empirical formula of iron oxide. And here I've written down the given. 168 grams of iron, excess of oxygen, 232 grams of iron oxide. This question leads you step by step through the calculation. First, the mass of oxygen in iron oxide is asked for, as the total mass of before the arrow is the same as after the arrow, and you know the amount of iron, and you know the amount of iron oxide, you can take the amount of iron oxide minus the iron, and that leads us to the amount of oxygen used, but also in the iron oxide, 64 grams. Question B asks you to calculate the moles of oxygen in the oxide. So you take the grams, you divide it by the AR value, so the relative atomic mass, which is 16, and then you find that you have 4 moles. Below here I've written AR is 16 gram per mole. The next question is similar, but then for the moles of iron, we have 168 grams of iron, because that's what we started with. If it reacts all, it all goes into the iron oxide. So 168 grams of iron divided by its atomic mass, 56, and you find 3 moles. in the last question, that's basically where you learn to do the empirical formula, it says calculate the ratio of the iron to oxygen to give the formula of this oxide iron. So you find 3 moles of iron, 4 moles of oxygen. So the ratio 3 to 4, and the formula is then Fe3O4. So there you found your empirical formula. Good luck.